Jack, wake up. Hooray, you're conscious. Now do you understand why you can't put metal objects in the microwave? You are surprisingly calm. After all, we are dangerously close to a black hole. A black hole is not a star, planet, or asteroid. It is a place in space where gravity is so strong that even light cannot escape this area. Scientists do not fully understand how black holes are formed. According to the most widespread theory, supermassive stars become black holes. When nuclear reactions stop in their depths, the pressure from within disappears, and the force of its own gravity compresses the star so strongly that it turns into a superdense object with incredible gravity. Scientists have been speculating about the existence of black holes since the end of the 18th century. Carl Schwarzschild was able to accurately predict this fact in 1916. While on the front lines of World War I, Schwarzschild became fatally ill. But despite the circumstances, he managed to solve Einstein's equation, which proves the existence of black holes. Heroes of science don't wear caps. In theory, any object can become a black hole if it is compressed to a critical point, the so-called Schwarzschild radius. This indicator is different for each object. So, our Earth can be turned into a black hole if you compress it to 1 centimeter. The same thing would happen if you compressed the Sun to just 3 kilometers. By the way, if suddenly our Sun turns into a black hole, then contrary to popular fears, the Earth will not be sucked in. Even the orbit would not change at all. Gravity is determined not by the size, but by the mass of the object. Drop it, Jack. We've already crossed the event horizon. That's the point of no return, after which it's impossible to escape the black hole's gravitational field, even if you're moving at the speed of light. The event horizon is not a physical surface. You won't notice anything unusual as you cross it, but from the perspective of an outside observer, things will be much more interesting. There will be a dilatation of time. In simple terms, slowing down. Time flows differently in strong gravity. You won't notice anything unusual, but to an outside observer, it will seem as if you have frozen and are gradually disappearing. This is because near a black hole light takes longer and longer to escape the strong gravity. Once you get beyond the event horizon, you can observe the entire future of the universe in a matter of seconds. In fact, if you manage to escape from it, you can get into the future. Don't be afraid, Jack. This is normal in a black hole. The closer you get to its center, the stronger the spaghettization will be. If you jump into a black hole feet first, gravity will act more strongly on your feet than on your head. This difference stretches your body into a long, thin thread, like spaghetti. The closer to the core of a black hole, the stronger the gravity. It will tear every atom of any matter into subatomic particles, sending them into the singularity. This is the heart of a black hole, a point of infinite density and incredible gravity. None of the existing laws of physics can accurately describe what happens inside a singularity. Scientists suggest that inside a black hole, we may find a wormhole that moves us through space, a portal to a parallel world, or a teleporter in time. Most likely, we will never know, since no information can leave the event horizon. Jack, don't hold up the line. Oh no, you put a fork in the microwave. Jack, wake up. Hooray, you're conscious. Now do you understand why you can't put metal objects in the microwave?